so I thought I was going to get makeup.
Hello and welcome to KAUST Live. We're coming to you from the Winter Enrichment Program. This year's theme is time. Now, it's one of life's most universal experiences, but how do we really know about the science, cultural impact, feeling of time, etc.? So here to speak to us about some of that is Joao Antunes, Media Lab team leader, self-professed chief troublemaker at CERN. Joao, thanks for joining us, man.
Thank you for the invitation.
Yeah. So you do quite a bit of traveling to bring the science of CERN to the world. So tell us, in the big picture sense, how you do that.
Well, first maybe I should introduce a little bit CERN. It's a big international organization.
Yeah.
So a little bit like at KAUST, people from all over the world converge to CERN to do awesome science and to collaborate in exploring the mysteries of nature. So the same way that people collaborate in the science, they also collaborate in the education, in the propagation of the results of this science. So one of the missions of my team is to conceive and develop awesome multimedia and installations to transmit to the people all around the world the thrill that we scientists feel when we do research. And in that sense, we have a few installations, of which one is here at KAUST. It's going to be in the library building in the library until the end of WEP, where people can immerse themselves into one of our big hits, no pun intended, because that's what we do. We hit protons a billion times a second.
Right.
And so people become particle accelerators.
Right. So this is, you're talking about, you're simulating something that happens in the LHC, or the Large Hadron Collider. So talk about that facility and how you guys developed this exhibit to bring it around.
The facility, the accelerator, or the facility, the accelerator is a particle accelerator, is something that accelerates particles.
Sure.
So it's a 27 kilometers long tunnel, which crosses the French-Swiss border. And what we do is we accelerate at very, 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 very high energies, particles, protons. Everyone heard in high school about protons, so we accelerate them, and then when they are at very, 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 very high energies, the highest energies mankind can imprint on these particles, we make them collide. And when they collide, something amazing happens. Stuff comes out of there. In a sense, we are disassembling nature to see it reassembling itself spontaneously, to study how nature works. So we do this a billion times a second. And our installation that we brought here is a game, is a way to let you become an actor in the process of discovery of what is it that we are doing in the bleeding edge of particle physics by playing yourself as if you were an accelerator and having the chance to talk to people which will be around you, trained to guide you through all the questions which we expect to trigger in your journey of enjoyment and discovery.
How do you separate the millions of interactions, particle interactions? How do you separate the ones that are sort of near misses and glancing blows and really hone in just on the ones that end up creating these Higgs boson and other things that you're studying?
Well, most of the particles actually don't collide at once. If they were, it would be a one-lap show. Right. We want to be getting data continuously, and we get it at a rate of about 1 billion collisions per second. Now, most of what we get is not really of great significance in terms of scientific discovery.
Right.
But this is what we call the background, which allows us to see the special stuff, how to say, getting enhanced against that background. You know, it's as if you had a crowd of people talking, and there is you know, a lot of chattering. There's a noise that is not interesting for you, but in the middle there, someone shouts your name. You will turn your head toward that person. There's a signal there in the voices that calls your attention, that is special, that is something that you are somewhat expecting. So it's a little bit like what we are doing. There's a lot of background noise in this data, and we are expecting some shouts in the middle of things which are interesting and which we think how they should somewhat look like, because there are theorists like journalists, which, by the way, is around here at WEP and gave a wonderful keynote talk.
Yes.
That these are the people that pretty much tell us what characteristics should we expect from the interesting stuff, so that we would be in the lookout for it. Yeah. So it's a feature that most of the data that we get is not of interest in terms of the advancement of science. In a sense, it kind of is, because it confirms the background, confirms the exceptionality of the other stuff we find.
You know, as science communicators, which both you and I are, I wonder, how do you decide between simpler to reach a lay audience and not as simple to make sure that you're getting the science correct? How do you go through taking some of these amazingly complex ideas and turning them into a well-communicated exhibit without missing some of the major points?
That's a very good question, and one that has been giving me a lot of thought over the years. Yeah. I think that the first thing that we should get in account is what is the message that we are trying to transmit, to what audience, and in how much time. I mean, if your objective is to give someone a PhD in 5 minutes, you're going to have a really hard task, right? But if what you want to do is to choose a few basic concepts which for your target audience can be easily assimilated, and you create a series of analogies and engaging activities around it, then you can, in the context of, let's say, an exhibit where people spend 5-10 minutes, you may transmit those. So I think the key is filtering, is selection. You should be precise, but you should not be precise on everything. Just on the stuff that you choose to convey your message. Otherwise, well, people should rather enroll in the university and get a PhD, right?
Right. So the exhibit that you've brought with you to KAUST, talk a little bit about exactly what people are doing in that and the interaction that it's explaining.
Okay, so one of the things that people do in there is play this game we call proton football. So what happens in proton football is that this is your chance, unique in a lifetime, to become a particle accelerator yourself.
Right.
So you have a proton, a virtual proton projected in the floor in front of you, and you can kick it with your feet. So it's a very it can be a very physically intensive activity. I've seen yesterday 5-year-old kids having a lot of fun with this. So it's very transversal. I've seen Nobel Prizes and heads of state playing this, and 5-year-old kids. Anyone can kick a ball, so you can kick a proton, right? Now, when you kick this proton, you see the energy that we imprinted to it. And if someone else kicks a proton that is in the other side and you make them collide, then you see something happening. You see something coming out of this collision, and most people wonder, what is this? What just happened there? So this is one of our objectives here, is to lead people to ask questions. And so, in fact, what happens is that everyone knows the most famous physics equation of the 20th century, E equals mc squared, which only means that you can transform energy into matter. Basically, that's it. And that's what people do in this setup So they give energy to the protons, and in the moment of the collision, this energy becomes matter, E equals mc squared. So you see these tracks that come out of there, these particles that come out of there, and these particles are new particles that are created at the moment of the collision, and they are not bits and pieces of the proton. This is what is almost magical. This is one of the key messages I want to transmit to people. Regardless of all the quantum effects, all the Nobel Prize winning theories, I mean, this basic concept that we can get something and transform it into something else completely different is deeply, even at the philosophical level, transformative. This happens all the time around us, right here, right now, and we are deliberately doing it in a laboratory 1 billion times a second.
Where did this idea come from? How do you take something and translate it into football or something completely different? Like how did the idea get developed?
Oh, this came about. About 6 years ago.
Okay.
I was with a group of students, and we were thinking about creating. So my team, the Media Lab team, had just been founded by them, and this was incidentally the year where we end up announcing the discovery of the famous Higgs boson,
right.
One of the greatest achievements in particle physics ever.
Right.
So at the time, there were rumors that we were going to announce something, and we were asked to do something spectacular at the time for the Frankfurt Book Fair. And we were told, hey, you're going to have a big stand and no pressure. The stand next to you is going to be the stand of Nintendo. You know, the guys playing games and so on. So you somewhat have to outshine them.
Right.
So we thought about the game, which would be Nintendo, they had the Wii, they had these very physical activities. So we thought about something like that, but without needing any of the accessories. So we got the idea of having these Kinect sensors, which is this is a sensor which was developed for the Xbox to detect the silly movements of players. And so we thought about doing a series of serious games based on it. So this is one of them. We have more.
Yeah, and talk about those. What other topics are you hitting on with this exhibit?
So, for example, people ask us a lot, so what applications are there of particle physics? Well, there are quite a few, including, I don't know if you ever heard about this little thing that has been around for 30 years called the World Wide Web. Some people may have heard about it.
Right.
It's kind of a side effect, but there are applications that are very deliberately being developed right now, for example, for medical applications, including some absolutely revolutionary therapies for cancer. And one of the games that we have here is a game called HEAL, Hadron Emissions Applications Lab, which is a game where people play as an operator in one of these facilities where we treat certain types of cancers.
Right.
So it's a revolutionary technique that is, by the way, I just heard from one of the volunteers here, who's a nuclear engineer, that he worked in a facility in Saudi Arabia, which does hadron therapy.
I see.
I believe it's in Riyadh. There's a facility that does this. So this is kind of a new thing, and we want also people to know that there's a lot of spin-offs from this technology that can reach them, can have a deep impact on their lives.
Right. Who outside of CERN, as a science communicator, who outside of CERN is doing this type of thing that's exciting, maybe that you admire or pull energy from? Anything notable?
In terms of science communication, well, there are many different styles of different communicators. I think we are somewhat pioneering this kind of approach. But there's a lot of other interesting things. I mean, I've seen the MIT Media Lab. There's a lot of really interesting things for people to explore the effects of general relativity and so on. But there are even mainstream games now, which became part of, well, even the tool set of some scientists and science educators. Like, I don't know if you ever heard about Kerbal Space Program. It's one of my favorites. It's a visual space program, which is very realistic. You can build your rocket parts. You can have a research and development program, like make a moon mission, a Mars mission, a launch satellite. It's a fantastic game.
Right.
We play it at the Media Lab, at the CERN Media Lab. We play a lot of games.
What brought you down this path? Give us sort of a quick sense for how you ended up being a science communicator, and what's the skill set that you ended up putting together to be able to build experiences for people, not just content, for instance?
Okay, so the thing that changed my life was to read at the age of 13 Cosmos by Carl Sagan. This made me decide to go on a scientific path.
Right.
And then it was watching, after reading the book, watching the original Cosmos by Carl Sagan, the TV series, seeing those graphics, those simulations of the colliding black holes, and this kind of excited me, and I wanted to do the same, like to communicate like Carl Sagan communicates, and like the team behind him does these graphics and so on. And so later on at university, so I was already programming since I was a teenager, and I decided to start programming simulations for little experiments that were being done at university. I had a professor that was asking me to do stuff which ended up in the Science Museum of Lisbon at some point. And so, okay, this launched me, and one thing leads to another, and then I was in Berkeley working as a researcher doing a scientific visualization, and now I work at CERN doing this.
Right. So then what is the future? What's the next big thing once proton football sort of plays itself out? What's the next project you guys are thinking to sort of
We have a lot of projects in the pipeline, too many actually for a very small team. But I tell you, one thing I would like to do very, very, very much, and it's not just a project, it's like a framework. What I would like is to kickstart something akin of international collaboration of science communicators, for multimedia for science communication, where other institutions, such as, why not KAUST, would contribute with a part of the manpower and the equipment, so that we all together use this platform that we have there and develop others and develop more content for it.
That sounds exciting. Well, thank you so much for joining us today.
Thank
we
you
really
very much for the invitation. My pleasure.
And that's all the time we have for today. Join us at 3 p.m. As we speak with Juan Carlos Belmonte of the Salk Institute. Of course, remember to like, share, and comment on all the KAUST social channels using hashtag WEP 2019. And from everyone here at KAUST, thank you so much for joining us.